This meeting is being recorded.
This is Newton and Nelson. Today we are covering chapters 17 and 18. The book is still Eloquent Ruby by Russ Olsen. So today we'll be covering two chapters. Chapter 17 is about using blocks to iterate, and chapter 18 is about the execute around technique, which relates to blocks as well. So all we are looking at for chapter 17 is a code block and calling a given method that you've already defined along with the code block. So I'm reading from page 207. The subsection is a quick review of code blocks. Since code blocks are one of the higher speed bumps on the road to real Ruby fluency, let's take a minute to review the basics. In Ruby, you create code blocks by tacking them onto the end of a method call like this, page 208. So we have a code block, and what the code block does, it's going to return this string. The string is named hello from inside the block. And then they show us a variation of this syntax whereby we don't have to use the do and keywords. So we just write do underscore something, and then we pass in what the block should return. So we have a method. This is still page 208. We have a method. The method is called do something. We define the method like we've been defining methods before with the def keyword. So we have a method. The method is called do something, and then inside the method we have the statement yield if block is given. And what this code basically does is that we are checking inside the method, we are checking to see if the method was called with a block, and if that is true, then we are yielding or returning what we defined for the block to return. And in this case, if we call this method, we are going to have the output hello from inside the block, because this yield statement is located inside the do something method. So when we try to see the output of this, we are going to have the string that we defined prior in the block. And then still page 208, we see that while calling yield, we can pass in arguments, which arguments will be later given or passed down to the block that is related to the method we are calling. So we have a method that is called do something with an argument. And then inside the method, we are calling yield, passing in hello world as the parameter, not the argument. But of course, just like before, we are checking first if a block is given when this specific method is called. So when we pass in hello world, the output we are going to get is going to be the message is hello world, because the message you passed in, or to be specific, the string we passed in is the string hello world. So what you'll get is the string named, or the output string called, the output string that says this message is hello world. So to give a recap so far, we've seen that you have a method, you define a method same way we've been defining methods before, and you call that method with a code block. And of course, you have to define what the code block should return. And inside the method that you've chosen to associate with this code block, you use the yield keyword and check if the block is given. If this returns to true, you're going to return what you defined in the block to be the output in your interpreter. So this takes me to a more specific example about the returning. So page 209, we have a method named print the value returned by the block. And in here, we're checking if the block is given, and then we are assigning the value to yield, and then eventually we are returning yield, the value as part of the string whereby we're going to have the block returned, and then we place in the value that was returned by the whichever computation we are trying to do. So we proceed to call the method, and we say print the value returned by the block, and then we pass in the block. I think this is pi 3.14159, and then we divide that by 4, which is basically says that perform the math operation named pi divided by 4. And the value that we're going to see in our interpreter is the block returned is the value of pi divided by 4. And remember, in Ruby, methods return the very last expression that was the very last I think expression that is at the end when the method is called, that is evaluated last by the method. And in this case, that is the string, which places the value that we've gotten at by performing this computation and places that value inside the string. So we see the value of pi divided by 4 as part of the string, and the final string will be the block returned 0.7 something something something, etc. So next session, one word after another. This is basically us looking at, now in more details after reviewing the basics, we are looking at the actual what the actual topic is about, and that is iteration with code blocks. So I'm reading from page 209. The subsection is one word, no, the heading is one word after another. The difference between the do something and the do something with an argument method and the real iterator method is simple. An iterator method calls its block once for each element in some collection, passing the element into the block as a parameter. And when you look at the each word iterator that the author added to the document class, we're going to try to see what the output of this is. On page 210, we create a new instance of the document class, and then we call the each word iterator method on that instance. And we're going to have the output, life is like a box of, and then the dots. So what we are saying here is that for each word that is part of the document instance we've created, we are getting the word and we are putting the word on its own line using puts. So for each of these words, we're going to have it displayed on its own line in the interpreter. So this is basically looping through the entire collection of words, of which words form the document, and giving you each of these words that make up this document. And that is an example, a very simple example of you trying to iterate through that collection of words which form the document.
Yeah.
So
So
we see that.
let me say something about this. So this is a good example here. Another set of examples that you can see in the real world is um, uh, the methods on the array class, because the array class has a lot of very useful methods like find, like each, map,
Yeah,
reduce, and all those methods are implemented in this way, where we pass in a code block and it does some operation. It loops, it iterates through the entire array, and it does whatever operation you you want on each of those elements in the array. Um, and it's the blocks allow us, instead of hard coding the behavior for each element, we can say, okay, like I don't know exactly what behavior needs to be done in, but I'm going to allow a user of this method to define their own code block at and so if they change their mind, they have control over what happens during each iteration. And it's very useful, and it's a very flexible way of saying, okay, I know that I'm going to define some code here, and at some later date or some other programmer is going to define some other code that is going to work in conjunction with this iteration uh, to produce uh, to produce new behavior.
Yeah. So I think, like Nelson has said, the refactoring of the each word method that you see takes from the concept Nelson has talked about, where we remember we had already defined a words array. So we call the each method that is provided by the array class on the given the existing words array, and then yeah, we perform the iteration as usual. So I think everything is clear so far. Is
Yeah,
that
I
the
mean,
case, Nelson?
I think so. Just stepping back a bit, um, we're at a chapter which is introducing this concept of blocks, and blocks is another organizational tool that we can use to well, organize our code in different ways. We've already seen that classes help us organize our code by grouping together data and methods. We've seen that modules have helped us group or it has helped us organize our code by defining, methods and then being able to include those methods into other class or to provide namespaces to be able to separate concepts out. We've also seen that methods are their own little grouping. And this is like the idea, at the start of the chapter, they talk about how it's not quite an object, it's not quite a method, it's this other like intermediate thing that is its own thing. But it like in the big picture, it's helping us describe another way that we can organize code. And in the examples, it's given us this idea of, okay, you have a method, you don't know what the you know what you want to do at the beginning of the method. You want to know you already know what you want to do at the end of the method, but in between, you're going to put this placeholder where you call some block, and that behavior can be adjusted on the fly or given as a block to this method to create new behavior. Okay, we're good.
Okay. So I think the next subsection is as many iterators as you'd like. This is still page 210. So initially, to our document class, we added the each word method, and then we proceeded to refactor it to use the each method that ships with the array class because we already have an existing words array. So we can take it one step further and we add another method that this time loops through each of the characters in the document. Remember, characters make up words and then words make up a document. So we take it one step further and we're like, let's define a new method. And this method is called the each character method. And we are iterating through all these words inside the document, or the characters inside the document, and we are doing whatever we want with those characters. We could be we could be that we want to return each of these characters in our interpreter for whatever reason. So you can write code to do exactly that inside the each character method. But what we are trying to see here is that, just like the chapter states, is that you can have as many iterators as you like to serve whichever purpose that you want to implement in your application. And then another thing is that we bring in a convention. This subsection brings in a convention whereby I'm reading from chapter 211, whereby the code here has a method. The document class has an each method and an each character method. So what we are saying here is that, quoting from the author, You are also free to name your iterator method anything you like, but it does make good sense to follow the Ruby convention and name your most obvious or commonly used iterator each, and give any other iterators a name like each something else. So given that it's agreed upon that words make up a document, for the we are going to rename the each word method inside the document class, and we are going to rename it to be the each method. Well, and this method is going to be associated with iterating over the words in the example we saw before. And then remember, we talked about taking it one step further and iterating through characters instead. So we are going to have an each method which iterates over the words, and then we are going to have an each character method which iterates over the characters. And this is the convention they're talking about, that it's agreed upon, words make up a document. So we are going to refactor our naming from the each word method to the each method. And then the next part is iterating over the ethereal.
Just as a
So we
side
see,
note, the each and each character are also methods on string. And string has a bunch of other each methods, like each byte,
yeah,
each character, each code point, each graph meme, each line. So yeah, that the string is another class that follows that convention.
yeah. So I think on page 211, at the very bottom, the very bottom of the page, we see some familiar syntax. And I'm quoting from a book. An aspect of iterators that beginners often overlook is that you can write iterators that run through collections that don't actually exist, at least not all at the same time. The simplest example of this sort of thing is the times method that you find on Ruby integers. So what we are looking at here, previously, our each method in the document class, we called the each method that is defined on the array class on our existing words array. We had the array beforehand, before we made the actual iteration. Now, in this subsection of the chapter, we are looking at a case whereby we don't have the array, but rather we are iterating one number at a time. In the context of this code at the very bottom of page 211. So we are iterating over each number at a time. In this case, when you say 12, and then you call times method, and then you pass in the number you're calling at, the number you're dealing with at that exact point as the argument, and then you output the number. So what you're going to see is that this is going to run consecutively from 1, you go from 1, you pass in 1, you output the number is 1, and then you go to 2, you pass in 2, the output is going to be the number is 2. So what you're seeing here is that you're going to go through this iteration consecutively from 1 up until the 12th number, with the major idea being that the array didn't exist before you started the operation. You didn't have the array beforehand, but rather you're iterating one integer at a time. Proceeding to page 212, this is really, I think, the same kind of concept. So I'm going to skip to page 213, and then I'll try to refer to the code on page 212. So here we are looking at the enumerable module, and like Nelson has said, some classes in Ruby come defined with iterator methods, and you'll have the string class has some of those, and the array class as well. So here we are looking at a case whereby we mix in the enumerable module, which is a mixin that endows classes with all sorts of collection related methods, and then we get access to those methods in our document class. So we have code here, we class document, and then we include the enumerable module, and then we have the each method that is part of the enumerable module. And then quoting from the book, the simple act of including enumerable adds a plethora of collection-related methods to your class, methods that all rely on your each method. So if you create an instance of the enumerable enhanced document, you can have access to these methods to perform whichever operation you want. A few examples of this include calling the include with the which is going to return true or false. You're checking whether the document includes a given word. Have true or false. Then another method that is provided by the enumerable module is the find all, and then the
Sorry, you're cutting out. Are you still there?
hello.
Hi, you cut out.
Oh, can you hear me?
Um, Hold on. You're still not 100% stable there.
You can't hear me.
Okay, I can hear you now. You're back.
Oh, yeah. So we have 8 minutes. I'm going to try to breeze through these. Yeah, the enumerable module provides collection related methods that you can use in your classes. You basically just include it within the class you're dealing with, and yeah, you get the magic. So I think an extensive list of those. Maybe something I wanted to look at was this thing on page 213, specifically the Hitchcock's method, which is which is going to be used in the refactoring of the each word pair. So for the each cons class, you pass in an integer and then you pass in an array, and then you yield the items in the array. So basically what this method was doing initially was that it was returning two words that are next to each other. Like it iterates through the array consecutively, dealing with two words at once. So you deal with two words, then the next two words, then the next two words, like that. And yeah, I think those are the main ideas in this chapter. We'll skip the staying section. No, son?
Yeah, I'm still here.
Yeah. I don't know if you can take us through the big idea behind chapter 18, and yeah, because the timer is ready.
Why don't we stop here and then we can uh, remake the meeting and start with the recording again.
Oh, for chapter 18.
Yeah.
Okay.